Okay, hello everybody to the EANS webinar. Probably it will be the last before the summer. As you know, today we have a very interesting topic, large language models in neurosurgery. I was very surprised that a colleague of mine asked me yesterday, what are we going to talk about? What kind of language models? Isn't it better to talk about AI or something like this? So I was very surprised, and probably we had to change a little bit the title, because in fact, what we mean frequently by AI are in fact large language models. By the way, this is very in congruity with the Alessandro Boaro publication for brain and spine and the study that he made last year with the support of EANS Group that demonstrated a very clear interest in the neurosurgical society and toward AI. But in fact, we are interested, but we do not know a lot of details, not only technical details, but even fundamental notion about artificial intelligence. I think that the conclusion of this article that is very interesting, and I suppose that Alessandro will accept to present it also to our auditorium, was that we need more knowledge. We need more information about AI. What is AI? What are large language models, etc. So I think that this gap that definitely exists will be filled today by our colleague Omar Arnaut. I will ask Omar to present himself briefly before starting the presentation, and then after the end of the presentation, we will have time for discussion. You know that there is a question and answer box at the bottom of your Zoom screen. So if you have any questions, please submit them in the question and answer Q&A box. And at the end of the presentation of Omar, we will discuss all your questions. Okay, Omar, the floor is yours.
Thank you so much, Nikolai. And thank you to you and Alessandro and the EANS and the task force for inviting me. And it's my first time giving this particular presentation, so I welcome your feedback, and I hope it's useful to your audience. But thank you so much for having me. I'm going to share my slides. Hopefully you can see those okay. Just for a really brief background, I got to know Alessandro really well when he was, with us in Boston. My clinical practice is exclusively focused on brain tumor surgery and skull-based surgery. I get the privilege of serving as an associate professor at the Harvard School of Medicine. I'm the director of the clinical operations for the Department of Neurosurgery at the Brigham. And in my research capacity, I help run our neurosurgery AI lab with a couple of my colleagues, Dr. Kevin Wong and Dr. Ben Johnston, who are both fantastic researchers. So I'm going to talk a little bit about the work that we do in our lab, but I'm going to spend a lot of time talking about general concepts and work that other groups are doing in hopes that this is maximally useful to the audience. So I'm going to discuss a couple of non-for-profit, but also commercial products that are currently available. I try to make this as practical as possible, but I want you to know that I'm not getting paid by any of them, unfortunately. But I have no disclosures relevant to this presentation. So here's the agenda for today. Again, the theme here is to make it as practical as possible. And I think this is really relevant because I believe that we are finally at this inflection point. There's been a lot of hype and talk about AI, both positive and negative. And I think it's often difficult to distinguish the reality from fiction or what the future might have in store versus what we are capable of today. But I do believe that we are at this point where there are currently existing AI capabilities that are meeting real life clinical needs. And as I go through this presentation, I'll try to highlight some of the things that I talk about that we're actively doing, today in our clinical spaces. The ChatGPT launched in 2022, and I think immediately people realized that there may be implications to the way that we practice and deliver healthcare. The American Medical Association did a survey actually in November of 2024, it was published in February of this year, that looked at different aspects of AI interest and utilization within a physician population. And you can see that even in the span of a year, it went from almost 1/3 of physicians are using some form of AI in their practice to almost 2/3. So there's clearly a lot of interest, Nikolai, as you suggested as well, in physicians and neurosurgeons in using AI. And I think we're finally moving from the idea of can this be helpful to how do we actually integrate this in our daily practice, and what are the strengths and weaknesses? And Nikolai, you mentioned this in the beginning, but there's people use these terms interchangeably. But I wanted to just take a few minutes. I promised there would be very little technical aspects of this talk, but just a few minutes on technical notes, because I think it is relevant. You know, the field of AI is vast and has been in existence for many, many decades. And machine learning was a relatively recent development. This idea that machines can learn iteratively from experience without somebody explicitly programming them. And the more recent revolutions have to do more with deep learning. Deep learning is a small subset of machine learning, which is a subset of AI. But deep learning is the idea that we can give these models huge amounts of data and have them learn from those vast amounts of data. In 2017, a technology called transformers became available that then fed into deep learning. So all we're going to talk about today is large language models specifically, and that is a subset of deep learning. So we're really focused on a very niche area within AI. But just as Nikolai alluded to, when people talk about AI, really what they mean to say is using large language models, because they are the most accessible and most powerful AI tools that most of us have at our fingertips. So just a couple of concepts and terms that you will come across as you learn more about this field. Foundational models, we'll talk a lot about foundational models, but those are the models that are ingesting huge amounts of data. ChatGPT, of course, is the most famous one. That's the one that broke this field into our collective consciousness. But they can ingest huge amounts of data in general. You know, text happens to be easily digestible, but they can ingest, video data, audio data, still images, and so on. So large language models are ones that are focused on text and written or spoken language. But there's also large multimodal models. So the most current versions of ChatGPT, for example, are more accurately described as large multimodal models because they were trained, they ingested different modalities of data. They are trained on visual data and audio data and video data. So in medicine, we will have great applications for multimodal models. They can, for example, take in medical images and an associated text, and I'll show you some examples, and then generate some useful information as a result. But I'll focus primarily on large language models, for the reasons I mentioned. They're the ones that are most easily accessible. But you also learn about fine-tuned models, and hopefully you will do some fine-tuning yourself of models. So that concept is where you take a pre-existing commercial or open sourced large language model, like ChatGPT or many others, and then you train it additionally on data that's relevant to you. In our field, maybe that's neurosurgical data or medical data, for example. And then it becomes particularly expert at answering questions relevant to that data. So in our lab, we do a lot of fine tuning, but all of you watching this are able to fine tune models, and I'll talk a little bit about that too. So I won't talk much about transformers besides the fact that it was kind of the critical technological advance that happened in 2017, published by the research team at Google, that allowed us to go from deep learning as a concept to large language models as we know them today. But you'll come across these other terms as well. Tokens are chunks of text. As you feed text into a large language model, it breaks it up into tokens. Oftentimes this is relevant because you have to pay for tokens. So this kind of sets your budget for a particular project. The term context window is often used, and it refers to how much memory, essentially, what the model can remember from your prior interactions. with them. So if you're, for example, going through a patient's case, you want the model to remember every part of the conversation you've had until you got to that point. And I mentioned already the idea of fine-tuning. So I think the last concept I'll talk about is this idea of RAG, retrieval augmented generation. So many of you, most of you have, I'm sure, heard about the problem of hallucinations. And what that means is that as you ask a large language model to answer a question or generate text, sometimes famously, it'll just make stuff up completely. And often it does that with extreme confidence. And that can include completely made up citations, anatomical facts, and so on, which is really problematic in medicine, just like it would be in other fields like law, for example, where the facts really matter. So hallucinations are not inherently a bad thing, because if you're engaged in a creative writing process, for example, hallucinations are actually kind of a good thing. But in our field, again, it's not good at all. So RAG is a recent development that allows you to take your model and instead of just going from prompt to response, you anchor the model in documents, and those documents can be, peer-reviewed journal articles. They can be any source of truth that you choose, locally or globally or whatever, and then you force the model to pick answers from those documents. Number one. Number two, you ask the model to show you where it got its responses. So by anchoring models in ground truth documents and forcing it to give you citations, we can be more confident that the results we're getting reflect reality and are available for audit, for example. So this is relevant because it's important to make sure that whatever model you're using is able to do this. It's also important because, again, you can do this on your own. You can go to ChatGPT today, give it documents, and ask it to perform RAG and answer based on those documents. Okay, so why should we care about this as practicing neurosurgeons? Well, I would argue that we have the need and the capability to implement this. So we have to make complex decisions, high-stake decisions on a regular basis. We, like many other physicians, deal with huge amounts of documentation. We have to integrate multimodal data for our decision-making, and we're needed 24/7. And on top of all this, we are expected to train the next generation, not only in surgery, but in medical decision-making and research. And these models have complementary strengths that work well in this context. They're able to very rapidly synthesize information. They're very consistent. They're always available. 2 o'clock in the morning, when somebody asks you a question, the model will be there to back you up. And they're particularly good at recognizing patterns in big data sets. There's lots of different models that have been validated and have shown to be able to perform at expert levels on medical assessments. ChatGPT famously passed the US medical licensing examination. I'm going to talk about open evidence quite a bit today, and that was the first one to break the 90% mark on the USMLE, for example. But there are others, and so we know that when they are trained, they're trained on a large corpus of medical information as well. And I won't talk too much about multimodal AI, except to mention that, again, in medicine, I think we have a real need for models that go beyond text, because then you can really start to bring in medical imaging, medical molecular data, and so on. But again, I'm focused more on large language models for today. Okay, so I promised practical applications. So there are some domains where these models are particularly useful for. Click documentation, I think, is one of the best examples. So there's lots of papers, I selected a few here, that show the dramatic reduction in documentation burden that these models can offer. So we're talking here about things that I think none of us find particularly exciting, but are really important in the daily practice of medicine. Things like writing discharge summaries that are accurate, operative notes, that are accurate. And those models are particularly good at taking large amounts of text in an electronic medical record, for example, consolidating it into really, really accurate discharge summaries. And it can do that, of course, in a tiny fraction of the amount of time that it would take a human to do that. So that's one example, but you have to remember that when we talk about language is more than written text. The same is true for voice to text dictations, and the same is true for, unfortunately, when you're dealing with the insurance world, the need to constantly write letters, and that goes both ways. We've become really good at using these tools to write insurance authorization letters, but then the insurance companies became really good at writing insurance denial letters using the same tools. But anyway, anytime you have a problem with documentation burden, there may be a large language model solution for it. This is maybe my favorite tool in medicine today, as far as large language models goes. And again, I don't have any conflict of interest or financial interest in them. I just really believe in the tool. So Open Evidence is a completely free tool. If you scan the QR code, it'll take you to it. It's a collaborative tool that was built at the Mayo Clinic, and it was trained on a large corpus of or fine-tuned, I should say, on a large corpus of medical data that includes high-impact journals, New England Journal, Nature, British Medical Journal, the JAMA, and others. It also includes publishers. And it uses RAG, which I mentioned earlier. So when you ask it questions, it'll show you answers and it'll show you where it got the answers, and you can go to the source documents. And I think it's a great example of a tool that you can use today, if you're not already, to ask questions. So this, to me, personally, has replaced other sources like UpToDate, where you would go to ask a question that relates to fund of knowledge. And beyond that, because it is a chatbot interface, you can even put in information related to the particular case that you're dealing with and ask for a differential diagnosis. It gets a little bit tricky if you're asking for very nuanced surgical decision making. So once you're really far in the weeds, but anything short of that, it's an incredibly effective tool. And on this topic, it's hard not to mention Atlas GPT, which is the first neurosurgery specific large language model. And it was originally, I believe, trained on the Journal of Neurosurgery backend, and now has multiple other partners as well, but very similar to Open Evidence. The big differences between the two is that this is a commercial product that comes with a cost, so that may be a barrier for some individuals, institutions. But on the other hand, this is very tuned to a neurosurgery population. So there's both tools are I think great to have in our arsenal today. So those are very practical large language models that you can use today. But the one comment I'll make about that is that, at the risk of stating the obvious, that even though those are high-performing models, they don't replace clinical judgment. So this is a paper from our friends within the Harvard system, and the quote in italics is how this paper was presented to a lay audience. So the headline in the paper was, the headline in the newspaper was that this ChatGPT is better at clinical reasoning than physicians. But if you actually go back and you look at the data, ChatGPT did fantastic. They used this scale called IDEA, where they presented vignettes to the model, and they looked for the correct diagnosis at the end. But I think more interestingly, they looked for the reasoning. So they wanted GPT to walk them through the reasoning of how it got to the right diagnosis. And they found that it did really well. It got the right diagnosis as often as attendings and residents did. And it walked through the same reasoning steps as physicians did too. Both are really impressive. But the reality is that if you look at the times where it went wrong and provided incorrect reasoning significantly more frequently than residents or attendings did. So So it should go without saying, but these are useful tools. They're really best used to augment human intelligence, but they are not anywhere near ready to be used as a replacement, or to say that they are performing more superiorly than human experts. Okay, so to go back to documentation, because I think that's the most practical way that we can use these today. I described already the idea that this can be used for operative dictations. I want to talk a little bit about ambient scribing, and hopefully many of you have seen what this looks like in real life, but this is a tool that I use every single day in the clinic. And there's lots of different products. We use one that's integrated within our electronic healthcare system. But the way it goes is you go in to see the patient, you have a device. In my case, it's my iPhone, and it's listening to the entire conversation. I don't give it any special instructions. I just put it on the desk and turn the phone on, and it listens to the whole interaction. By the time that we're done having our normal patient-doctor interaction, the patient leaves the room, you turn to the computer, and your note, the history of present illness, the exam, review of systems, the assessment and plan have all been written. They've all been transcribed by this ambient system, and they work really, really well. And I think they've been really good at significantly reducing the burden of writing clinic notes. We talked about discharge summaries already and insurance letters. But I mentioned in my example about ambient scribing that our system is integrated into the EMR. That's really important. You know, these tools are, in my opinion, only useful if they are well integrated and easy to use and intuitive and don't require 10 other steps. The example I gave is a good one where everything just kind of works. And I think that's important. It's also a challenge because that makes it much harder for you to bring these into a clinical environment. And I'm being a little bit simplistic when I say the note is done. The note is largely done. I mean, it's 90% done, but it's still, you're still responsible for the content of it as the physician, and you still have to go through and edit it and make sure that it reflects, you know, reality. So, but 90% done is still great. It's better than 0% done, which is where, you know, my clinic was before. And then, of course, anytime you have a new technology, it's important to get everybody trained. So there are always going to be challenges to how to go from, you know, a research environment to a production environment. But in the example that I gave for ambient listening, this table on the right is from Microsoft, who makes the software that we're using, and a study that they did about the outcomes of integrating these into clinic. And you can see that clinicians really like it, that it freed up a significant amount of clinic space, more slots for more patients to be seen. And at the same time, the clinicians felt good. They felt that they can focus on the clinical care and less on documentation. Another really good use case for language models is to improve communication with patients. So this is a nice paper from last year where they looked at translating or rather reframing surgical consent forms in a couple of different ways. The main one was to change the language so that it meets a certain grade reading level. In other words, make it more easily comprehensible to patients. They had the consents reviewed by legal teams to make sure that it doesn't, you know, it didn't change the nature of what was being communicated. And then they surveyed the patients and found the patients understood much better what they were signing than they did before. So that theme can be iterated over again. So we use this, and I'll show you in a little bit how we use this to try to improve patient understanding across multiple domains. You know, patients now get copies of all their results, MRI results, pathology results. They get your notes, and they often have a hard time understanding them. And the more engaged the patients are, the better the outcomes are. So this is a great tool in converting medical language into language that's accessible and to a more lay audience. So the same is true for converting from whatever language you're using, in, you know, English in my case, to other languages. So translation, real-time translation of medical information is a great use of large language models. And even to go a step beyond that, you can not only translate different language, but also adapt a little bit to the audience culture. And in doing so, you can make it really personalized. And hopefully, as a result of that, more engaging to the patient and the family. And this is an example from our lab where we looked at taking brain MRI results, doing this conversion to simplified language. And on the left, you can see the violin plots about how much more accessible those reports are. And we did sentiment analysis. In other words, what feelings does this report generate in the audience? And we found that there's a substantial increase in neutrality and a substantial decrease in fear. So, to us, reading a brain MRI doesn't elicit, anxiety, but to the patient, it often does, and that's understandable. So if you can make it more comprehensible and less anxiety-inducing, I would argue that that's a good thing. And again, we talk about the idea that language is not only written. So these models are really great at, again, converting from voice to text and text to voice. And for patients with visual disabilities, that's a really helpful thing. And then the last thing I mentioned on this communication piece is that we all have, as surgeons, post-op instructions that we spend a lot of time designing for our patients. It'd be really great if you can take those instructions and then personalize them based on, for example, events that happen during that hospital stay or particulars related to the patient. And that's another great use case here. Okay, I'm going to pivot a little bit to talk about research and how these are useful for research. There's a lot of different domains here, but again, anything where there's a big document burden. So when you talk about performing systematic reviews, large language models are a great starting point to get you at least going in the right direction. There's a paper recently that compared the traditional way of writing Cochrane reviews, which are incredibly time-consuming, to one that's supported by a large language model. And you can imagine that it would significantly decrease the amount of time that goes into those. Similar for meta-analysis. I'm sure many people are already using it, but if not, they're really great grant writing accelerators and assistants. Unlike using a word processor like Word, where you can look at spelling and grammar, for example, these models understand the context of what you're trying to do and can often give you directed feedback and help you synthesize the evidence that you're working with. In different ways, we're using this technology. So we have OpenAI models in the back end of our EMR. So by having it kind of within the firewall, we're able to feed it some patient-specific data. So you can imagine if it was built into your EMR, it's a really helpful tool, for example, to look at all the operative notes, for example, or all the MRI reports that have ever been produced in an institution. And if you can do that, then it becomes a really useful way to pick up things. For example, you can pick up complications, you can pick up adverse events, and you can start to use it as a way of potentially curating that data, identifying cohorts that you're interested in studying more. So in this case, it's a research accelerator, but instead of looking at the literature, you're looking at your own institutional data, for example. We mentioned already, but the idea that you can use it as a writing assistant, I think, is very prevalent. I'm going to skip over this because I think the most exciting thing is the emerging applications. So all the things I mentioned so far about research are really kind of basic. I think the exciting thing is when you can work collaboratively with a large language model and come up with new testable hypotheses. That's really advancing the field in a direction that we may not have gone in before. Again, these models can be really good at recognizing pattern in large data sets. And if you can do that, then you can work collaboratively on coming up with research questions and then coming up with ways of analyzing them. And I think that's an exciting area where now we're really performing novel scientific investigation based on this idea that we can collaborate with large language models. Okay, so the next topic I wanted to talk about briefly is medical education. We talked about the idea that these models possess a huge amount of medical knowledge, a huge amount of neurosurgical knowledge to begin with. And I've talked to a lot of different trainees at different levels that are using this every day. And I think that's a really great thing. But you can, off the shelf, take any number of these models and have it work with you as a trainee to provide tutoring, to come up with questions that you can go, for example, board prep, board review questions. You can go through an entire patient scenario. The model can mimic a standardized patient, and then the trainee can go back and forth with that patient and get a history and come up with a differential, for example, in a way that you can't do with static written textbook. This idea of adaptive learning has become really prevalent in kind of education writ large, and medical education in particular, where the next question you're asked depends on the question you just answered. So if you got the answer right, the next question becomes more difficult, and vice versa. That way, the question is always adaptive to take that trainee in a personalized fashion to the next level. And I think all those are examples of things that are very practical that can be implemented or are being implemented currently. I wanted to show an example. This is not neurosurgical per se, but I think there's a lot of great lessons here. An example of a real-world clinical implementation of a local large language model. And so this is work from the group at Northwestern in Chicago, where they wanted to train a model locally, specifically for chest radiographs, and they fed it the entire population of chest radiographs they had. And this is a multimodal model. And really what they wanted to do is feed it a chest x-ray and have it come up with a radiologist style interpretation. So this is what it looks like. There's kind of text data that goes in, there's x-ray data that goes in, and on the right side you can see the report, which very much looks like a radiologist sat down and wrote this, and those reports would then be read by a radiologist and approved or changed. And they found that this resulted in actually really accurate reports, a significant reduction in the amount of time it took to make those reports, as you can imagine. So I think one of the reasons I bring this up is to say that I think the future for large language models probably is a combination of local implementation, a human in the loop, like I mentioned, where the radiologist is still reviewing the data, and then a lot of institutional specific training. And that way you're getting something that augments the existing, not replaces, but augments the existing workflows. And I think you can replicate this example in many other domains in medicine. It's important to remember that when we talk about this, when we talk about things like GPT and other models getting really great results on standardized testing, that it's a little bit unfair because they're trained on that same standardized testing and the same corpus of knowledge. It's the real world is obviously very different than getting curated vignettes like you would get on an exam. There's this study from last year that showed that when given more complex vignettes, that the likelihood of the model adhering to established, agreed upon guidelines, like the NAS spine guidelines, was actually not great. And the more complicated, the more nuanced the case became, the less likely it was to be compliant. So this just emphasizes the need for a human to always be in the loop and for supervision of these models. We talked about hallucinations and the way that RAG can mitigate that problem, but it's important to remember that the models can be very, very confident, but very, very wrong. So just keep that in mind and always double check the sources. And we talked a little bit about implementation, but as exciting as a lot of this stuff sounds, at the end of the day, I think the key is to get it implemented. And you can have the best model in the world, and as long as if it doesn't fit into your workflow, then it's not really usable. And there are some major issues, as you can imagine, with technical implementation, with the cost, that comes along with this. And the fact that there needs to be a trust component both from the practitioner side and also from the patient side, and that continues to be kind of a work in progress. At the end of the day, the responsibility always resides with the physician in terms of the clinical decision making and the information being conveyed, so that the trust is an important part of it. This was it's kind of an old study now, but it was a really interesting study. You think about de-identified data sets as being kind of safe, and that's what we use to train a lot of models. But this is an example of how models can actually re-identify patients, and you have to worry a lot about that in healthcare data. So as these models become more prevalent, early on, for example, we realized that if you take MRI data and you strip the metadata and use them to train a model, if you don't take the faces off, then those MRIs can be made into 3Ds and the face can be an identifier. But in this paper, they looked at physical activity data, and they were able to reverse engineer the medical record numbers just from the physical activity data, for example. So the point is here is to be really careful with your patient data. Even if you've de-identified it, you don't want to make it publicly available because of this risk for re-identification. We do a lot of work on federated learning, which is this idea that instead of data leaving institutions, the model leaves the institution and comes to your place, for example, learns locally, and then goes to the next place and learns locally. There are other more kind of advanced techniques. For example, differential privacy is an idea that you can induce noise into your data set, and in doing so, add a layer of anonymity and complexity to it that allows still for sharing data with less of a concern for privacy, but there's some downsides with that. Anyway, the point is privacy and security continue to be major issues when you're dealing with protected privileged information like medical information. I mentioned this earlier, so maybe I'll skip over it a little bit, but like Nikolai mentioned in the beginning, this is an area of great interest to physicians, and I think there's lots of applications for it. I don't want to overstep and talk too much about the EU, but just given the audience for the presentation, my understanding, my feeling is that the EU has been a little bit more cautious, maybe compared to North America, and it's not a bad thing, obviously, but there's a little bit more caution in terms of applying large language models to medical applications. The World Health Organization, if you haven't seen them, put out guidelines for the use of AI in health, which are actually really helpful. So it's good to try to thread the needle of pushing the field forward and using these, but at the same time being mindful of the nature of the data that we're dealing with. Okay, I just wanted to talk a little bit about the stuff that we're doing in the lab and try to wrap up in a couple of minutes. But this is kind of how a day in my life looks through the lens of large language models. So we have a model that we fine-tune locally that we call Heads Up. And every midnight, it goes through every MRI report, every CAT scan report done at our institution. And it identifies, we asked it to identify newly diagnosed brain tumors and then forward those brain tumors to the Center for the Tumors of the Nervous System, with the idea that patients can then be more rapidly triaged to the right provider. Maybe it's a neurosurgeon, maybe it's a radiation oncologist, and so on. But this is something that's up and running. I mentioned DAX Copilot, which is the product that we're using. There are others. That's the one that Microsoft makes. I use that for all my clinic encounters, and it's been a really productive tool. I mentioned Open Evidence, which is my favorite tool for clinical decision support, and it's also really great for education. If you're sitting with residents or in conferences, it's great to kind of have that layer of data support the conversations. We have a model that I mentioned. We call it GIST, which is how we run our medical results, MRI pathology results, through GIST and make them more understandable for patients. And then finally, I didn't talk about this very much, but we have a model called HERTZ, which is a model that triages spine patients. So it ingests the entire medical record for a given patient, all their results up until the day they come see you in clinic as a spine provider. It then has a patient-facing interface where it'll have essentially a conversation with the patient, collect an HPI from the patient, and then the end result is to try to triage which patients are surgical and which ones are better off with conservative management. And the preliminary results have been really promising there. So just some concrete examples from our daily lives in using available and also kind of investigating the use of new models. Okay, so I'll conclude by talking about kind of what the future has in store. I think within the year, we're going to see more of what we've been seeing. Talked about the technical limitations and what advances I think will help overcome those. We talked about integration, how improved integration is going to help more people get their hands on this, and some of the privacy concerns. I think those are the things that lots of groups are working on today, and I think are surmountable, issues. I think the really exciting stuff, probably on a 5+ year horizon, which have to do more with multimodal models. You can imagine how if you add video or vision to a language, then maybe that's how we're going to end up with a surgical guidance system with real-time feedback and so on. I could talk more about that, but I'll leave it there for now. But I want to show you really quickly the only video I have which has nothing to do with surgery. So in the little free time that I have, we love to go on the water, and the boat we're on has this camera. So this camera lives on top of the boat. It has an infrared camera, and it has a large multimodal model that's running locally. And as you're out on the water, it identifies other boats, it identifies hazards, obstacles, it tries to keep you safe. So this is a non-surgical and non-medical implementation of a large multimodal model that I thought was really cool. We used this kind of all weekend, and there's no reason why your microscope or your endoscope doesn't have something similar. I think on a 5-year timeline. So okay, I'm gonna end there and say thank you again for having me. I hope this was useful, and I'm happy to have questions, Nikolai, if there are any.
Thank you very much, Omar. It was an amazing presentation. Everything is going so fast that I don't know how we're gonna catch up. I have a question for you, because you're an expert in neurosurgery, and I will say in one of the most challenging field of neurosurgery, the cranial-based surgery. So what do you think? And on the other hand, you're an AI expert. So what do you think about us, the rest of the neurosurgical society? Should we remain more, should we become more or less experts also in AI and digital technologies, or is better to wait for the products to see them more mature and someone else to implant them in our everyday work? So what is your suggestion? What do you think it will be better for us?
Yeah, no, thanks for the question, Nikolai. I think that so the way that we have this research group, and within the research group, there are people at different levels of interest and background, and I think everybody can participate. I think it's important for neurosurgeons to participate because we would get to design tools that we know are useful for our patients. So I think that's important. But I don't think that necessarily means that you need to be a computer programmer or take a year off and study matrix algebra. That used to be the case. But that's no longer the case. I think people with different backgrounds and different interests can be involved and should be involved at different levels. I think there are tools like the ones I mentioned that are mature today and would be great for people to start using, and understanding the strengths and limitations. And I think things like fine-tuning or adding RAG, they might sound complicated, but they're actually very simple, and I think are accessible to anybody with basic kind of computer knowledge. On the other hand, if you're somebody who's really interested in, like the work we do in the lab where we design models from scratch, that's also tenable. It's a lot more tenable than it was, 10 or 15 years ago. because these same tools can also help you become good at that. But anyway, I do think it's important, and we've been working with this society, the SNS, the Senior Society in North America, to try to figure out if there's a way for us to implement a curriculum that the trainees all have access to, so that everybody finishing training can have a basic understanding of what these tools are. And hopefully we can have that up and running in the next year or so.
Thank you.
Omar, thank you very much for your presentation. As usual, very clear, very on point, and really cutting edge. So thank you very much for that. So we'll go through some of the questions that we received. So the first from the chat, which is it's regarding privacy. In part, you probably already answered, but we would like to have your take on that. And the question is how to address data security when using ambient scribing. How do we make sure the confidential data is not saved anywhere? It could be accessed by a third party.
Yeah, no, I mean, I think privacy, thank you, Alessandro. I think privacy is a major concern. And I think that's why, for something like ambient listening, first of all, we always give the patients, we let them know and we get their approval for us using this technology in the first place. Second of all, the way that we've been using it, at least in the way that I suggest it's used, is not by using third-party applications where you don't know where the data is going. So we are using it, and I think the way that it should be used is by using a tool that's integrated within the EMR. It's an official tool that's vetted by the hospital. In my case, the information goes directly into Epic, which is our EMR. It never leaves Epic, so it goes directly. I'm using the Epic app on my phone for the recording, so it's always inside of Epic. So it's the same as me typing into Epic. I think if you try to use a third-party application like that you download from the App Store, for example, I think that's a major concern. And there's not a way to go around that. And I think that's, for example, to Nikolai's point, I think there are some tools that are worth waiting for them to be mature and formally implemented before using them. Other tools you can experiment with if the privacy is less of a concern.
Okay, thank you very much for the clear answer. We have a couple other questions, which are, what do you think about using AI in improvement on medical devices? So I believe in the process of making them and producing them and designing them, and so as well as surgical techniques. We have then another couple of them, and we'll give back the floor, the word to the floor, please.
I'm sorry, Alessandro, could you repeat the question? I didn't catch it.
Yes, apologies. What do you think about using AI in improvement of medical devices? So I believe in designing new medical devices and improving surgical techniques.
Oh, gotcha. Well, though I don't know about medical device improvement per se, but I'll tell you that there's this idea of edge computing, which really refers to, instead of having these big models run in a cloud somewhere, that you have smaller, more nimble, more specialized models that are running on medical devices that are at the bedside. So that's not answering your question. That's a little bit adjacent to what you're saying, but I think we'll see more and more of that. I think there's this other idea, like the video I showed with computer vision, that maybe that is a path towards something like mentorship, where the models are trained on these big video libraries with master surgeons doing complicated techniques. And then while you're doing your operation, the model, having trained on those, can give you feedback. And maybe that's a way for us all together to get better and elevate the field. So I hope that answers the question, but that's my thought on that.
Yeah, absolutely. Just going towards the ability to move the technology near the bed in the OR. So I see that Enrico Tessitore from the floor has a question.
Yes, thank you for this very nice presentation. And I have more a comment in the question is about publishing, because yesterday we had the chance to have at our grand rounds Wilco Pearl, who is one of the co-editor of Brain and Spine Journal. We were talking about the role of artificial intelligence in publishing, editing papers, and we were talking especially about meta-analysis and systematic reviews. You mentioned it in your presentation, how fast the artificial intelligence, ChatGPT, whatever, they can replicate and build a systematic review. And we know that systematic review meta-analysis are very well appreciated by editors because they're very highly cited. But because they will probably lose of quality thanks to because of the ChatGPT artificial reviews, probably this kind of papers will be less accepted in the future. So my question to you, this was my comment, the question is how do you think this kind of implementation of the artificial intelligence might actually create a sort of fake world of easy publishing in a context of race for publication in academic profile?
Yeah, no, thank you. I think that's a really thoughtful comment, and I know that the editors of the major journals are thinking about this and struggling with this. I don't know that I have any easy answers. Dr. Barker is right next door, and he's the incoming editor for the White Journal, and I know that's a topic that's top of mind. And I do wonder if there's a world where systematic reviews maybe are just very different than they are now. Maybe they're not even published. Maybe it's whenever you're going to systemic review to ask a question, you're able to generate one on the fly based on the most recently available information. So I think that'll look very different in the future. But in the meantime, I think your question is a really good one, which is how do you, as an editor, combat this deluge of submissions and publications that are really kind of AI based and keep the content really high quality. I think that's a complex problem.
They actually have softwares dedicated to recognize the specific words or phrases that are repetitive. And so this is something this is a new actually strategy that editors should implement to avoid this kind of cheating.
Yeah.
Enrico, we had a webinar in the beginning of this year that was dedicated on this topic, how to recognize a text that has been generated from an AI. And I think that this is the answer of our expert was that this is a very tough question because all the systems that exist to control this process, the large language models are evolving so fast that they cannot catch up so easily. So I think that this will remain a problem also in the future, and probably we shall need something else. I mean, these type of studies have been very good for us as physicians because they give us a high scientific value. But if we can acquire this high scientific value in an easier manner, just asking a machine, what's gonna happen?
Do we need all this paper then?
Exactly.
Right. Yeah.
I see Marcel Ivanov from the floor has a question. Please, we have time for another couple probably.
Thank you so much, Alessandro. Omar, thank you so much. It is really fantastic presentation on a topic which I think is extremely hot. I mean, as frightened I was a few years ago when it appeared, as excited I am now to be part of this. And I think to the comment of Nikolai, the question is it a reason not to accept a paper which was generated by AI if it is a good quality paper? But Omar, my question to you is a bit technical. I mean, these platforms, they are rapidly evolving. Almost weekly there is something new coming in, and it's really difficult to keep tracking them. The question is, they work very well in English. Do you think they work this in the same way in other languages as ChatGPT, which will do in probably any language? All these medical applications, are they equally good in other languages, or it is predominantly English?
That's a really good question. I don't know that I know the answer to, but it's funny you say that because I had a slide on this and I ended up taking it out for the interest of time. But I think that the reality is, like, ChatGPT was trained on, more or less the entire contents of the internet, and the contents of the internet are going to be biased towards, more English language content. But there's obviously, everything else exists on the internet. So I know that there is a huge effort, a multi-billion-dollar effort in China, for example, to have a Chinese specific, a Mandarin large language model. Japan has a similar effort. In the Middle East, in the Gulf countries, Saudi Arabia, they also have a huge investment in Arabic, focus, and I'm sure there's, multiple other examples. And just subjectively, I don't have any data for this, but subjectively, when we've done the translation work that I mentioned, and when I have patients who are, who are Arabic speaking, and I'm fluent in Arabic, and we've done this work in GIST to try to help them understand their medical, and I read it myself. Even the off-the-shelf OpenAI models seem to do really, really well on Arabic, which is not an easy language. So it's a long way to answer your question by saying I don't really know the answer, but I'm optimistic based on all those things that it'll be. And I think that's really important because you want it to be democratized technology. You want everybody to have access to it, and that's the attraction. And I'm optimistic about that possibility.
Okay. Omar, it was an extremely interesting overview of what we have today. But as we mentioned several times, things are going so fast that I hope that you will accept to be our guest very soon, because I'm sure that there will be a lot of new things that for you to share with us. But what I can see and what all of us are seeing in their everyday practice is that these new models are changing our everyday work in different manners. We see it also in the devices, in the suggestions for, especially in spine surgery, suggestions how the calculation of different of the sagittal balance, suggestion for different type of implants. It's going so fast that as I see, we are doing nowadays a completely different spinal surgery than we have done, let's say, 10 or 15 years ago. I think that the next time that I will think that we are doing a completely different spinal surgery will not be in 15 years, but probably in 5 or even in 3. So we have to stay in touch, and we shall rely on experts and you to show us a little bit the way and what is going on, because for us people that are not that are experts only in neurosurgery but not in AI and these digital technologies, what is going on is sometimes frightening, and it's difficult for us to catch up. So thank you very much for this extremely nice, interesting overview, and I really hope that we're going to have you very soon again.
Yeah, no, thank you. Thank you so much for the invitation. I really hope it was useful, and I'd love to come back anytime. I really appreciate the invitation, and it's really good to be here with you guys.
Thank you very much. And now I remind you that for our meeting for the EANS Congress in Vienna, it's in October, beginning of October. So please subscribe yourself. It's time to do it, because there are still lower prices for the for registration. So please check the EANS.org website. Thanks to all of you. Bye until the next time.
Thank you.
Thank you, Omar. Thank you, everybody.
Thanks, everyone.